Hi, I'm Kian, and in this video, I'm back with how to find the critical points of multivariable function. So we know how to find the critical point of single variable function just in terms of one variable. We usually take the derivative and we set it equal to 0. So either it can be when the derivative is 0 or when the derivative is undefined. But when we have more than one variable, and that in this case you have function x and y, it becomes a little different. So what we have to do is that we have to first take the partial derivative with respect to each variable and make sure that both of those partial derivatives are 0 and the points that make basically that equation true. So basically what we want to find is a point x comma y in which the partial of f with respect to x is equal to 0 and the partial of f with respect to y is equal to 0. Basically like kind of an example of partial differential equations. So this is also considered kind of a, not because we know what the function is, but we want to find kind of points or conditions for it. So let's begin. So let's take the partial derivative with respect to x. I'm going to use maybe yellow here. So if we do, y squared is just a constant, so it becomes 0. So we just get 2x, this is that with respect to x, and then plus we get the derivative of yx is just y with respect to x, and then this equals 0 because we wanted to equal to 0. And the partial of y, so this is basically this. I'm just going to use the arrow, and this is the partial of y. So partial of y, taking the derivative of y squared, we get 2y. Derivative of xy, we get plus x. And then the derivative of y, we get an plus 1, but I'm going to subtract the 1, so we get this is equal to negative 1. So this becomes actually a simple problem because this is a system of equations with two equations, and what we can do is that we can actually use elimination. So we can multiply this equation by 2, and if we do so, if we multiply this equation by 2, what we get is that we get 4x plus 2y is equal to 0. And so if we subtract the two equations, so this 2y and 2y goes out, what we get is just 3x is equal to 0 minus 1 is 1. So basically x equals to 1/3. So now that we found our x, we can just plug into either of the equation to find what the value of y is. And let me use maybe black here. So if we plug into this equation, we get 2y plus 1/3 is equal to negative 1, or 2y is equal to negative 4/3. And so as a result, y is equal to negative 4/6 or negative 2/3. And so if I'm going to write it as a point, I'm going to write sol for solution. The x and y are 1/3 and negative 2/3. And you can make sure that this is true for the other equation too by plugging in. So you get 2/3 minus 2/3 is 0. So this is true. So for this function, y squared plus x squared plus yx plus y, at the point 1/3 and negative 2/3, there is a critical point. And in the future video, I'm going to kind of consider how we can classify those critical points, either as a local minimum, local maximum, a saddle point, or is it just we can't able to kind of classify it. And I'm going to cover those in future videos. So thanks for watching, and please subscribe to my channel, and hope you have a good day. Bye.